Hello and welcome back to this, my Carbidopa sofa. Thank you for joining us on our second exploration into disease. In today's video, we will start looking at the pathophysiology of Alzheimer's disease, or AD, to better identify what it is and where it stems from. In our next video, we will dive into its symptoms, the possible therapies that can be used to help treat it, and hopefully slow its progression. But, not to mention, we should probably learn a little bit about that progression as well. This will be structured similarly to the Parkinson's video. First, we'll identify a basic definition of what it is, and then we'll learn about the different parts of that definition one by one. So what is Alzheimer's? As we will be saying it a lot in this video, remember that AD is what we're going to say instead of Alzheimer's. A good working definition of AD could be identified as a neurodegenerative disease leading to progressive neuronal death with noted progressing dementia.
Luckily, we defined fully neurodegenerative in the pathophysiology video of Parkinson's, but we'll revisit it again briefly to refresh those noggins of yours. Neurodegenerative is the scientific term for loss of the function of neurons, which are the primary component of the nervous system. Neurons are, regularly speaking, on the ball when it comes to passing messages between themselves, usually through the use of neurotransmitters. Those are little chemical text messages sent between the neurons. Neurotransmitters exist in multiple types. In the PD videos, we became somewhat close with the neurotransmitter dopamine, while with AD, we'll focus a little more on the neurotransmitters acetylcholine and glutamate, but more about them later. I thought now would be a good place to list off the primary neurotransmitters, as we will hopefully discuss them all in some detail in the future. Besides dopamine, acetylcholine, and glutamate, there are also serotonin, GABA, and endorphin, and epinephrine and norepinephrine. All neurotransmitters serve their own general functions and are normally signaled for in a variable amount of ways. Like PD, we generally define as neurodegenerative disorders affecting dopaminergic neurons, leading to a loss of dopamine. AD too is highly correlated with the loss of one specific neurotransmitter, that being previously mentioned, acetylcholine. As dopamine is produced and released by dopaminergic neurons, acetylcholine comes from cholinergic neurons. If you saw the PD therapeutics video, you might remember Brandon introduced a class of drugs called anticholinergics. These antagonize or decrease the effects of acetylcholine. As loss of acetylcholine is correlated with Alzheimer's, this class of agent is not what we would want to use to treat it. Along with acetylcholine, glutamate is also a more prominent character in what goes wrong in AD. Depending on a neurotransmitter effect on a target, they can be considered excitatory, aka activating, or inhibitory, aka inactivating. Acetylcholine can play both sides of the field depending on what's acting on it, while glutamate is wholly excitatory. This will become more important in just a wee bit.
The last part of our definition is specifically dementia. The word dementia derives from a Latin term meaning out of one's mind or madness. This term is used to describe a large collection of conditions which cause memory loss. Alzheimer's dementia is a specific type of dementia, and thus not all dementias are considered Alzheimer's. Just like how dogs might have 4 legs, but not all 4-legged animals are dogs. No matter how certain your cousin Timmy is, that giraffe is not a dog, just with a really long neck. So now that we understand a rough idea of what Alzheimer's disease is, let's try to better identify what causes it. Are you guys ready? Can I get a drum roll, please? Well, we don't know. That's it. End of the episode. Curtains close. Someone call Edison, because the world has been enlightened. But in all seriousness, like many aspects of the body, we don't have a solid answer on what causes Alzheimer's disease. However, we have a few theories and we have a bit of evidence to back our thoughts on what plays a role in it. The easy explanation is there's evidence that not one thing causes Alzheimer's disease. Rather, a collection of things are attributed to it. Much like the Teenage Mutant Ninja Turtles on the NES, pathophysiology can be unnecessarily difficult, but I'm going to do my best to briefly explain some of the primary aspects of Alzheimer's. The acetylcholine hypothesis. The progression of Alzheimer's is marked by an identified reduction in the activity of choline acetyltransferase, also known as CHAT, as well as a deficit in the acetylcholine overall. CHAT synthesizes or creates acetylcholine in the cerebral cortex and hippocampus. Therefore, as acetylcholine transmission is diminished, attentional learning and memory are affected. With glutamate, typical neurotransmission is important for learning and the memory process. As with acetylcholinergic neurons in Alzheimer's, there's an identified decrease in glutaminergic neurons as well. The synaptic cleft is a space between the shipping dock of one neuron and the receiving dock of the next neuron. Interneuronal communication is done through the releasing of neurotransmitters into the synaptic cleft, where these neurotransmitters can bind to specific receptors on the next neuron. This binding allows for the message to be carried onward. In Alzheimer's, there's evidence of reduced numbers of glutaminergic neurons, as well as a decreased capacity for the neighboring cell type, the glial cell, to take up any excess glutamine left in the cleft. Remember, glutamate is excitatory. Without the necessary mode of removal, glutamate can just pummel its receptors in the cleft, creating a lot of concentration background noise, excitotoxicity, which can cause neuronal death.
Amyloid beta is similar to a car's exhaust in this example. It naturally occurs as a byproduct of the physiochemical processes of the brain, cyclically being disposed of without excess accumulation. But in AD, and especially noted in inheritable forms, accumulation does occur. These deposits, or plaques as we call them, are damaging to neurons, forming extracellularly or outside of the cell, and occurs early on in AD. Hereditary forms can come from defects in multiple genes. The one correlated with amyloid beta is APOE, also called APO. APP, PSEN1, and PSEN2 are linked closely with early onset Alzheimer's, a form that develops usually prior to the age of 65.
And now we have the tau protein hypothesis. Similar to the amyloid beta plaques, the tau proteins are the byproduct-like collections of molecules that form intracellularly within the cell. Typically, there are methods for the cell to deal with this. However, those methods become strained in Alzheimer's disease.
This just in, breaking-ish news. A recent study showed evidence that AD could at least be partially caused by viruses, which is not all that crazy if you think about it. Viruses have been correlated with severe neurological conditions before. For time's sake, I had to cut this section, but please check out the link in the description below to SciShow's video about it. Tell him we sent you. I still have a tie I need to give to Hank. I've also written a blog post about it on our website if you'd really like to read that as well. There are a few other prominent factors that are correlated with the disease, its progression, and its severity. But for the sake of time, I chose to focus on these specifically. Umbrellaed over all of these causes and the ones not mentioned, we can see one shared end outcome. This being cell injury and death. With many forms of injury, one of the ways our body tries to limit it is through inflammation, or the swelling of tissue. Inflammation is a multi-step process that can vary depending on where it is in the body and how it was induced. Within AD, the induced inflammation response can worsen the process through which it was initially triggered for. This causes a horrid little cycle. Okay, that was a lot of information thrown at you really fast. I hope you have begun to understand through our first few videos just how complex we as humans can be. We are immaculate machines, and we do our jobs well. Sometimes things go awry, and sadly that's just a part of this journey we call life. In this video, you should have learned a working definition on what Alzheimer's dementia is, and you should be able to name some possible causes of it. Heck, we even fit in some basics on neural function and communication. Join us next time when we will learn a bit more about the symptoms of AD, its progression, and how it's diagnosed. As well as, we'll talk about some of the ways that we treat the condition. As always, thanks for joining us here at the sofa, and we'll see you some other time.